4 chlorines or 6 chlorines or 8 chlorines or 10 chlorines, the more chlorines, the less volatile the PCBs are. In the next column, the same is true for water solubility. So those with few chlorines they're still not terribly soluble, but they're relatively more water soluble than those that have 10 chlorines. And that's because the log octanol water coefficient, that's a number that tells you would they rather be in a fat solution or in a water solution. And then the evaporation rate, that's related to the vapor pressure. And you see that the low chlorinated PCBs, this is in grams per cubic meter per hour, the low chlorinated PCBs are much more volatile than those that have more chlorines. Now, for most of our history with PCBs, that dating from the late 1920s until really about the year 2000, most people thought that the PCBs that really caused health effects were those that stay in our bodies. Because I could take a blood sample from anyone in this room and measure PCBs. The PCBs that we have in our body tend to be those with more chlorines. Our body can slowly degrade PCBs and excrete them, but it does it very slowly. So if you look at a total mixture of PCBs, it takes about 10 years. If you ate a fish out of the Housatonic last night for dinner, it would take 10 years for you to get rid of half of the PCBs that were in that fish. Now, if you look at those PCBs that have 10 chlorines, it would probably take either decades or even centuries, because they simply cannot be degraded in our body. Now that's got some benefit if you want to figure out who was exposed and who wasn't exposed. Because if I take a blood sample from anyone in this room and they have high PCB levels, that will include not just what they had for dinner last night, but a lot of it will include what they had for dinner 10 years ago, 20 years ago, 30 years ago, because these things stay in your body. Now, on the other hand, those low chlorinated PCBs, the ones with 1 chlorine or 2 chlorines, are very quickly broken down in our bodies. And in fact, very rarely would you ever find one of those low chlorinated PCBs in a human blood sample. Now, for those that have 3 and 4 chlorines, they're still relatively rapidly broken down, but some of them, depending on where the chlorines are located, are relatively persistent, and they have a half-life of maybe 1 year or 2 years. So that when you find them in your body, that is an indication that you were relatively recently exposed to those particular PCBs. Now, it should be a little apparent from what I'm saying is that those PCBs that are in food, which is basically all kinds of animal fat, that's in your eggs, in your butter, in your whole milk, in your pork, in your beef, in your chicken, and certainly in your fish. Those animals also can break down the PCBs with few chlorines relatively quickly, but not so quickly those with more chlorines. So most of the exposure to people in the past has always been assumed to be from eating animal fats. And I'll come back to that in a little bit. Okay, now Monsanto sold commercial mixtures of PCBs that were calculated to contain an average amount of chlorines. So low numbers had relatively low chlorination. Those were, they were oils, but they were more fluid, whereas those mixtures with high chlorines tend to be pretty viscous oils. Now, this next slide shows you one of those commercial mixtures. This is in the top line there. This was Aerochlor 1260, and I have in my office some pure Monsanto Aerochlor 1260. And that 1260 says that 60% by weight of that commercial product is chlorine. Now, the PCB congeners, the PC mixtures that were used in this area were primarily Aerochlor 1254, so 54% weight is chlorine, and 1260. So these are relatively highly chlorinated mixtures. Now, what you're looking at on the left side, that's PCB1 that has 1 chlorine. On the far right side, that's PCB 209. So first of all, you look in the commercial mixture and you see their peaks. It isn't that each one of those PCBs has the same relative quantity in this Aerochlor mixture. Some of them stand out much higher than others, and that's just because this process of putting chlorines on the biphenyl ring by temperature and pressure work better for some particular positions than for others. Now, you don't see anything down there at the bottom for the low chlorinated PCBs. So what my colleagues did was take some pure Aerochlor 1260 and blow air over it, and then collect the PCBs in the air. And surprise, look at all of these PCBs that have few chlorines, down at 1, 2, 3, 4, and 5. You couldn't even see these in the commercial mixture because their presence was not that great. What you see is that the whole curve from the top thing has shifted downward to lower chlorinated congeners. There's still some of these higher chlorinated congeners that go in the air, but the more chlorines that they have on them, the less likely they go into the air. Now, this is relevant for what people here are exposed to. You can be exposed to PCBs. Oh, I think I have a slide on that. In fact, it's the next one. You can be exposed to PCBs by 3 different mechanisms. You can eat them, which is basically eat or drink. You can breathe them in, or you can absorb them through your skin. Now, most of the exposure from eating PCBs is from eating animal fats. Now, PCBs have so contaminated the world that there is almost no piece of animal fat that you can eat that doesn't have some amount of PCBs in them. The reason for that is multiple. First of all, they get in the air, they migrate around. Secondly, we have this horrible habit in this country of recycling waste products. I was on a committee of the National Academy of Sciences a few years ago on dioxin-like chemicals in the food supply, and PCBs are dioxin-like, some of them are. And we were told that modern butchering of beef cattle involves, they have a good beef cattle with nice fat in the steaks. They have a lot of other fat that's of no value unless you use it to put it back in animal food. Well, so what they have been doing over the many years is putting that waste animal fat that contains all the PCBs that animal was exposed to into cow food. So we're recycling the animal fat, and that recycles the chemical contaminants. Now, a few years ago, there was a big concern about mad cow disease from eating cow fat. So they stopped putting cow fat in the cow food, and they started putting it in the chicken food, and the pork food, and the lamb food. And so it just has spread so that all of the contamination that we had 40 years ago is still being recycled in the food supply that we have. I find it disgusting, but that's how a lot of us have these more highly chlorinated PCBs in our body. Now, they can be in your drinking water too, but again, as I showed you, it's the lower chlorinated PCBs that are more water soluble. Just a story. The city of Waterford, New York, just north of Albany, was deriving its drinking water from the Hudson River, which is as contaminated as the Housatonic from General Electric plants in Hudson Falls and Fort Edward. Well, the town supervisor was concerned because they were just about to dredge the Hudson River to remove the PCBs. And he was afraid that the dredging would stir up the PCBs and their drinking water in the town of Waterford would become contaminated. So he asked us to do a study before and after dredging. We went and got some water from the faucet in the town hall to measure PCBs before the dredging, and we found 20 parts per trillion of PCBs in that water after it had gone through the water treatment plant. The supervisor was horrified because he was assuming there were no PCBs in the water. Well, if you're on a well water, there's no treatment. If you're on a municipal water supply, there is always a filter system, so you will collect and remove any PCBs that are bound to particles, soil particles, and that sort of thing. And that's pretty true in any municipal water supply. But unless you have a very active, very potent active charcoal system, it will not remove the PCBs that are dissolved in the water. That supervisor didn't ask us to come back because he didn't want anyone to know we found PCBs in the water supply. But this is another route of exposure. Now, we all drink water, unless you do it in the form of beer or coffee or tea. But even there, you're going to get PCBs. So that's another route of exposure. I'm going to focus a lot on inhalation because while EPA until very recently would not even consider either drinking water or inhalation of PCBs as being any way a source of exposure. They're turning around a little bit now because the evidence is so overwhelming they can't deny it any longer. But we all breathe. We have to breathe continuously all the time. We breathe when we're outside, we breathe when we're inside. And it's long been known that PCB concentrations in indoor air are greater than those in outdoor air. Now, most of my studies have been of outdoor air, and I'll show you some of the results we get there that are due to inhalation of PCBs. The third route of exposure is having them absorbed through your skin. For most people, that's not a big issue. If you go barefoot wading in contaminated sediment, you may absorb some PCBs, but most people don't do that often or very much. All right, so the question is, what is the safe level of PCBs? My answer to that is the difference between no molecules and one molecule. PCBs have no beneficial effect. Now, one molecule of PCBs is not going to cause a disease. I don't mean to say that. But one molecule is going to start to perturb our physiological system. And so there is no safe level of PCBs, and any exposure is bad, and more exposure is worse. I've already sort of touched on this. How long do they stay in your body? Average for the whole range of PCBs of the 209, about 10 years. Some decades or centuries, some days or weeks. And these lower chlorinated ones are going to be days or weeks or maybe up to a year or even a year and a half. But one of the issues I want to develop tonight is just because something doesn't stay in your body very long, does that mean it has no biological effect? And I think the clear answer to that is no, it doesn't mean it has no biological effect, because PCBs act in very interesting ways. We all have in our bodies what are called nuclear receptors. These are primarily things like hormone receptors. So the receptor for estrogen or the receptor for testosterone, the male and the female and male sex hormones. These are inside our cells, and when estrogen or testosterone activates that receptor, it induces all of the genes that make the difference between men and women and boys and girls. Many different genes, not just one or two. Well, PCBs act on estrogen receptors, on androgen receptors, the male sex hormones, act on a whole variety of other nuclear receptors, and they cause induction of genes. And as I'll go on, I'll tell you about the great variety of diseases that we have demonstrated to occur in people exposed to PCBs. And the reason that this one chemical can cause so many different diseases is it changes many different genes, and those genes influence almost every aspect of our health and well-being. So a PCB that enters your body that you can break down in a week still can have time to do all kinds of damage. And if that PCB is in the air and you're breathing it every day, it's never going to go away. So just because they're relatively rapidly removed from your body does not mean they don't have an adverse biological effect. All right, so let me start by telling you the kinds of studies that I and my colleagues have done. And I decided tonight, since our situation in New York around the Hudson River is so similar to the issue around the Housatonic and the other places where I have studied along the St. Lawrence River, the same issue, Anniston, Alabama, which is one of the places in the states that Monsanto had a plant, and I've studied the people there. So the issues are very much the same. So rather than talk about work that other people have done, I'm primarily going to talk about just what my group has done. I don't mean to minimize the many people that have added to understanding of the health effects of PCBs, but I think I can speak more knowledgeably about my studies. So we've done two kinds of studies. The first one was simply looking at the diseases people get if they live near to a PCB contaminated site. Now, that kind of study, we don't measure PCBs in the person, we simply know where they live. In New York, we have a whole data set called the SPARCS data, which is that if you are hospitalized or if you go to an emergency room, that hospital must report to the state health department every disease you have, up to 15 different diseases. So if you break your leg, but you have high blood pressure and diabetes and a pimple on your nose, all of that information is put in that database. And we've used that database to determine the relative rates of hospitalization for different diseases based on where people live. So that health data comes from the New York State Department of Health. It's called SPARCS. It has information about age, race, gender, date of birth, and how you paid for your hospitalization. It doesn't have your name, although that information is collected by the health department. They don't give it out. It doesn't tell you your home street address, but it tells us the zip code in which you live. So now there are other things it doesn't tell you, like what your income is, because we know that poor people often have greater risk of diseases than more affluent people. So we use the census data to determine the population density in zip codes now, that's our unit of exposure, and determine the average family income, which is a measure of socioeconomic status. Now, that still doesn't tell us how frequently people are smoking, whether they're exercising, whether they have a good diet, and that sort of thing. There's another data set that's organized by the Centers for Disease Control, but operated by the State Health Department, called the Behavioral Risk Factor Surveillance System. And we can get rates by county and by zip code of smoking, of exercise, and that kind of thing. All right, so that's our health data. How do we get environmental data? Well, this is a map of New York State, and what you're seeing are the geographic areas of zip codes, and all of the red zip codes contain at least one identified hazardous waste site that has PCBs. Notice that long red line on your right? That's the Hudson River. 200 miles from Fort Edward to Manhattan. Like the Housatonic, totally contaminated with PCBs. There's been dredging, there's been some removal, but there's a hell of a lot of PCBs yet in the Hudson River. And then many other hazardous waste sites. Our State Department of Environmental Conservation has a listing of 800 and some hazardous waste sites in New York State. It does include the federal Superfund National Priority List sites, but there are also a number of state sites that are identified and we know what contaminants are there. The blue areas are zip codes that have a hazardous waste site, but they don't contain PCBs. So that's a comparison group. So what we did is match the rates of hospitalization for different diseases against the zip codes that either have PCBs, they have a hazardous waste site but doesn't contain PCBs, or they have no hazardous waste site in that zip code. And then we've looked particularly at those zip codes along the Hudson River. I describe the Hudson River as a beautiful hazardous waste site. People that live along the Hudson usually pay a little more for their houses. They're usually wealthier. They're better educated. We found that they smoked less. They had an average income that was greater. They exercised more, and they ate more fruits and vegetables. So they had a healthier lifestyle. The question is, how did that influence their risk of disease? So this is coronary artery disease and myocardial infarction, heart disease and heart attacks. Now, most people don't think of PCB exposure increasing your risk of heart disease. And this doesn't prove it, because this is only looking at the rate of heart disease depending on where you lived. So I need to describe what these odds ratios are. Those are the numbers on the right side. So you're always comparing against the people that live in the zip codes that don't have any hazardous waste sites. And we take that as our reference. Now, when there is an increased hospitalization for coronary artery disease, that number will go up. If there's a decrease, that number will go down. And then the numbers in parentheses are what we call the confidence intervals. And statisticians have as a standard rule that if the low number there is greater than 1.0, we consider that to be statistically significant at the 95% confidence interval, which is to say the chances are 95 out of 100 that that's a real observation. So what you see is there's a 15% increase in hospitalizations for heart disease if you live in a zip code that has a PCB containing hazardous waste site. Excuse me. There was no significant increase if you live in a zip code that has a hazardous waste site but it doesn't have any PCBs. If you live along the Hudson River, you have even a greater risk of heart disease than if you lived by a zip code with PCBs that weren't by the water. And that's a 36% increased risk among the people that are wealthier, that practice a healthier lifestyle. When you look at heart attacks, it's the same thing. This is strong evidence that living in these areas with hazardous waste sites increases the risk of heart disease. Now that isn't proof because we don't have measures on individual people. But we looked at a variety of other diseases. Again, diseases that most people don't even think of as being related to PCB exposure. How about high blood pressure? Same thing, 19% greater risk of having high blood pressure if you live in a PCB site. Now in this case, there was also an increased risk if you lived by other hazardous waste site, and there was an elevated risk along the Hudson. Here's diabetes. Same pattern, although there was also an increased risk if you live in a zip code that has a hazardous waste site without PCBs. But again, along the Hudson River, it was even greater. Now, what does this mean? Well, this kind of study is called an ecologic study because we're looking at large populations that we don't have any information about the individuals that live in that zip code. They don't ever prove anything, but they're hypothesis-generating studies. And so we need to find other ways of really testing the suggestions that come from these studies. Now, why would you anticipate that you might have elevations of these chronic diseases of older age? Because most people that live by a PCB contaminated site don't eat contaminated fish. They don't go wading and absorb PCBs through their skin. So our hypothesis was the only way you could explain this is if PCBs are responsible, they must be breathing the PCBs that are in the air. Now again, remember this is outdoor air. We don't have measures of indoor air in these studies. So our hypothesis is that there are PCBs in the air and people are inhaling them. So the question is, what are the air levels of PCBs? Now this is sort of important because I want you to remember these numbers. Look at the bottom. If you go to remote sites in the US or North America, the level of PCBs in the air are less than 0.08 on average. The range from 0.05 to 0.12. So I usually say the average is about 0.1 nanogram of PCBs per cubic meter. All right, what are the levels of PCBs along the Hudson River? And I'll bet they're about the same as you have along the Housatonic. Well, in the upper Hudson where the GE plants were, they were only up to about 4 nanograms per cubic meter. So that's 40 times higher than the background. And you go down the Hudson River where it's less contaminated, they still were of the order of 0.6 to 2.2 nanograms per cubic meter. Now that's not a very large amount, but I'll talk about the number of molecules of PCBs in a nanogram a little bit later. But so this is the level, remember these air levels, because I'll show you a little later air levels in houses in Pittsfield. And so the background is less than 0.1. The levels along the Hudson River that's very contaminated of the order to 1 to 2 nanograms per cubic meter. All right, let's move to Anniston, Alabama. So not by a body of water, but this is the plant that made most of the PCBs that came to this area. It's a city of about 24,000. There's another Monsanto plant in Illinois. I was involved as an expert witness in a number of cases on PCB exposure in Anniston. Monsanto lost almost all of them, but Senator Shelby of Alabama ordered the Agency for Toxic Substances and Disease Registry to do a health study in Anniston. And it was done by a consortium of universities, including mine. And I was given the responsibility for investigating cardiovascular disease in Anniston. And so we had 772 residents, about half African American, half Caucasian, ages 18 to 93. The PCB analyses were done by CDC. We took measurements of blood pressure, which of course we didn't have in those studies on hypertension I just showed you. And we had information about the medications they took, their obesity rates, and all that sort of stuff. And this is just an indication of how contaminated Anniston is. Landfills all over the place. Most of them were not lined on the bottom. They were emitting PCBs to the air from the landfills. There was PCBs that leached out into little streams in a local lake. These are the results from our measurements of blood pressure in these 772 people. The red dots are systolic blood pressure. The black dots are diastolic blood pressure. And if you can see it, there are dashed lines there, which indicate what is clinically defined as being hypertension, both for systolic and diastolic hypertension. All right, the first thing that strikes you, and that line is statistically calculated, the higher the PCB, the higher the blood pressure. And this is true even for those people that did not have clinical hypertension. Which is to say, this proves our hypothesis from those ecologic studies that exposure to PCBs causes high blood pressure. Now, shown more rigorously, and I would suggest you only pay attention to the column, the second from the left, and look at the bottom numbers. So we divided this group of people into three groups: those with the lowest amount of PCBs, those with the mid amount, and those with the highest. What we found, if you compare the lowest to the highest group, 5 times the rate of having high blood pressure in the people with high PCB levels. Now, what was surprising to us initially is you look the lowest to the middle group, it's almost as bad, which suggests that the amount of PCBs you have to have your blood pressure go up is very low. And this probably is why nobody had ever seen this before. And if you show that on a plot, so this on the left, that's the ratio of high blood pressure by PCBs from the middle tertile and the highest tertile. And you see that's a much greater risk than BMI, which is fatness, than total serum lipids, your cholesterol and your triglycerides. It was more important than sex, it was more important than race, and it didn't relate to smoking or to exercise. Now, this is a striking result indicating how important exposure to PCBs is in relation to development of hypertension. Now, what are the air concentrations in Anniston? Again, for comparison to what we're going to show later in Pittsfield. So right by the plant and the largest landfill, 27 nanograms per cubic meter. Now, this is high relative to that background of maybe 0.1. And 1.5 miles away, it was down to an average of 9 nanograms per cubic meter. So from a contaminated site, PCBs in the air spread some distance. I didn't have a slide in it here, but my colleague Mark Hermanson has developed the method of being able to measure PCBs in tree bark. Trees don't move. There's enough fat in tree bark so they accumulate PCBs over time. And Mark did a study on trees away from the Anniston plant. And he found high levels near the plant. They went down and finally reached background levels about 3 miles from the plant. And you can use that data to figure out distance from a landfill here in Lee, or distance from the Housatonic River, where airborne PCBs are going to spread. All right, a lot of my work over the last 20, 30 years has been with the Native American group in the north part of New York State, southern part of Ontario and Quebec, the Mohawk Indians at Akwesasne. They live downstream from 3 aluminum foundries run by General Motors, by Alcoa, by Reynolds Metals. They all use PCBs as hydraulic fluid, so that's a different use than what you had here in this area. They were primarily 1248, an air chlor mixture with only 48% chlorine. When the hydraulic fluids leaked, they washed them down into the St. Lawrence River. The Mohawks are a traditional fish-eating population. They ended up with very high levels of PCBs, and we've been studying them in collaboration with the tribe for a number of years. All right, so I want to actually talk about the diseases I showed you from our SPARCS data. because I already showed you that we found living near a waste site, even if you didn't measure your blood pressure, when we could measure your blood pressure, there was an association with your body burden of PCBs. Now, I showed you also that living near a hazardous waste site in New York increased your risk of being hospitalized with diabetes. So we did a study with these Mohawks. We've done this over a number of years, and we showed quite a while ago that there was an elevated rate of, Native Americans in general have high rates of diabetes. And we showed quite a while ago when we just looked at total PCBs that there was an elevated rate of diabetes. Now, what this slide says is what everybody knows, that diabetes is thought to be because you're too fat, because you don't exercise, because you eat too much. Well, that may be a factor, but that is by no means the only factor. And so we wanted to find out when we could measure PCBs and when we had medical records and we could get fasting glucose levels, was there an association there? So this was our lab. We measure 101 PCB congeners. We also measure 3 chlorinated pesticides. DDE is the metabolite of DDT. HCB is hexachlorobenzene. These are also chlorine containing. They're very persistent. And they are reported to cause a variety of diseases. Now, the Mohawks did not have any unusual exposure to the pesticides. Well, this is looking at the level of PCBs by age in the Mohawks. And it's very striking how older people have more PCBs than younger people. And there are 2 reasons for this. One, older people have been living longer, and so they have more time to accumulate PCBs. The second reason is that when they were young, there were more PCBs around. They were still being manufactured. So anyone in this room, we would find on average older people have more PCBs than younger people. All right, how about this idea that obesity is the biggest risk factor for diabetes? Well, in our study, we found that the highest rates of diabetes were in those people that were in the overweight category, not in the obese category. And even the extremely obese people didn't have as much diabetes as those in the overweight category. So there's a lot of evidence that obesity is not directly related to development of diabetes. In fact, if you think about it, why are people obese? It's usually because they eat too many animal fats. What's in the animal fats? PCBs. So there's an association with obesity, but it's not the direct association. What about diabetes and PCBs? Dramatic. Now again, you see the same things we've seen all along, more striking at older people than younger people, but this is by quartiles of PCB concentration. And in the highest group with the highest quarter of people with PCBs with diabetes, independent of their age, they are at greater risk of developing diabetes. So then I take this to have proven our hypothesis on 2 diseases, hypertension and diabetes, where we had reason from these ecologic studies to hypothesize there was a relationship. Here we have taken fasting glucose levels, we've looked at medical records and diagnosis of diabetes related to their PCB level, and we find the association. Okay, then the next question. So we had done this work early on, and this shows those results, that our initial results looking at total PCBs and total pesticides suggested that the pesticides were worse than the PCBs. But we sort of asked the next question, well, which PCBs are important? And so we analyzed PCBs that had 3 and 4 chlorines. We already had collected that data, as compared to those that had 5 to 6 or more than 7. And what you see is there was a 5-fold increased risk of diabetes for those people that related to their concentrations of the PCBs with 3 and 4 chlorines. There was no association with those that, when we looked at the higher chlorines. that strongly suggests that inhalation of PCBs is the risk factor. Now, I should talk about the P for trend. If that number is greater than 0.05, that means it's not significant. So no significant association with high chlorinated PCBs. There is an association for hexachlorobenzene, but it's not nearly as striking as that for the 3 and 4 chlorine PCBs, where you had a 5-fold risk. Now, there is another concern. Some PCBs are like dioxin. Dioxin was what was in Agent Orange, a proven human carcinogen. So we looked at those that were dioxin-like versus those that had few chlorines that were non-dioxin-like. The dioxin-like PCBs had no significant effect. Their 95% confidence limits include numbers below 1. But for the non-dioxin-like that are low chlorinated, they had an odds ratio, a risk ratio of 5. 5-fold greater risk of developing diabetes, probably by breathing in PCBs from the air. So these results strongly suggest that inhalation of PCBs is responsible for the elevated risk of diabetes, and that it's these lower chlorinated ones that are important, and that inhalation is the important risk factor. Now, in the studies in aniston and hypertension, we didn't have all the PCB conjugers because that was not our lab that did that, but we surveyed the Mohawks on self-report for their hypertension. And by self-report, which is less good than measurements of blood pressure, of course, but by self-report, it appears that hypertension is also related to low chlorinated PCBs and breathing them in. We all must breathe every minute of every day of our life, and that can be a route of exposure. All right, so what are the air concentrations at Akwesasne, the reservation there? So now, air concentrations, of course, are less in the winter and cold weather than they are in warm weather. So by the General Motors landfill, we had 19.6 nanograms per cubic meter. But at that same site in the winter, it was down to 1.2 nanograms per cubic meter. That makes sense. Other sites further away from the General Motors site had values between 0.6 and 4.2. So much above background, but not as high as at close sites to the landfill. I want to tell you about one other case. This is a legal case I was involved in of a man and his wife. Both worked for a company that had to deal with waste oil from capacitors and transformers that might or might not contain levels of PCBs above and beyond the 50 parts per million, where it has to be treated as hazardous waste. And the man was the chemist, the woman was the cleanup person. They were both told to smell the oils because PCBs have a subtle smell, but if you work with them very much at all, you can distinguish that. And these were young people in their early 30s. The man developed first thyroid cancer, then malignant melanoma, then lung cancer, and he had never smoked, and he died of metastasis to his brain. The wife, who was a little younger than him, developed thyroid cancer, developed the pre-malignant melanoma cancer. She's still living. We got blood samples from them to measure their PCB levels, and let me show you those results. So PCB 28 and 52, these are low numbers. So these are relatively volatile PCBs, but they also have chlorines in a position so they're not degraded as rapidly as some of the others. And look at their levels, 1.82, as compared to the average background in the US of that particular PCB of 0.03. So he and she both had sky-high levels of these lower chlorinated congeners. The same is true for PCB 52. Their levels are much, much higher than the average person in the US. Now, PCB 153 has 6 chlorines, so it's one of these higher chlorinated congeners. And their levels are right in the background level for the US population. That PCB you get by eating food, contaminated animal fats. So this is very good evidence that both of these people with those unusual cancers, they're man and wife, but they were not blood relatives. For non-blood relatives to have the same cancers means that that can't be explained by genetics. They both had high exposure to low chlorinated PCBs. So although there's not any other evidence, and this is only 2 people, I take this to indicate strongly that inhalation of PCBs can cause cancer. We know that PCBs are rated by the International Agency for Research on Cancer as known human carcinogens. But this, I think, the first evidence that it's the lower chlorinated PCBs that do it. So PCB levels in air cause disease. That's true in our Native American population, our Aniston population, just in general looking at people in New York State on the basis of hospitalization. Now, as I said, EPA has always ignored inhalation as the route of exposure. They now have issued some guidelines for PCBs in the indoor air in schools. The lowest level they suggest for young children is 300 nanograms per cubic meter. Way, way higher than what we have demonstrated in all of these sites. For older children, their guidance level is 600 nanograms per cubic meter. This is just outrageous. And like most federal agencies, they lag behind the data. Now, I have good friends at EPA. I know they're considering this, but the wheels of making change in recommendations move very slowly. It's very important for people to understand how serious inhalation of PCBs is. Okay, so how many molecules are in 1 nanogram of PCBs? Well, it's 2.26 times to the 12th. That's trillions of molecules of PCBs in 1 nanogram. Now remember, the background level in remote areas is about 1/10 of a nanogram. So divide that by 10. That's the amount of PCB molecules in the air in the most remote place you can go to. And then as you go up to higher PCB concentrations, take 20 nanograms per cubic meter, you have trillions of molecules of PCBs in the air. Remember I said the boundary between safe and unsafe is 1 molecule in my judgment. So even these low levels, they may not be reflected as high levels in your blood, but they're a pile of PCBs. Okay, let's move on to Pittsfield. Studies that actually were done quite a while ago by my colleagues Ann Casey and Brian Bush. Unfortunately, both of them have died. And I've had this data in my file cabinet for years, and I never really got around to writing it up. I'm writing it up now. I don't know whether you can see these numbers, but let me give them to you. So what they did, they looked at 13 homes in Pittsfield, and they got blood samples from the people that lived in the homes. They got blood samples from 21 people. And then they measured the air in the basement, in the living room, and outside the house. Okay, the average blood level was 4.2 nanograms per gram. Now, I haven't talked about what background levels. At this point in time, the Agency for Toxic Substance and Disease Registry said the average background was between 0.9 ppb in women and 1.5 in men. So clearly, these people have elevated PCB levels. The basement air was 125 nanograms per cubic meter, much higher than anything I've shown you yet, except the EPA standards for schools. Remember, the background is 0.1. What we saw around the contaminated Hudson and Anniston, contaminated St. Louis, was maybe up to 20. This is 125. The living room air was 54. And the outdoor air was 16. So pretty much like those that we measured around the Hudson River. The outdoor air was clearly very elevated, but what was really elevated was in the basement. Now, there weren't significant elevations of the pesticides that we didn't have any reason to believe that there would be. But there were slightly elevated concentrations in basement air as compared to living room air. This is a map of the PCBs in the basement air. Now, you can't read those numbers, I'm sure, but about in the middle is PCB 81. And anything lower than that has less than 4 chlorines. So this is even worse than what I showed you by blowing air over Aerochlor 1260. Sky-high levels of these low chlorinated congeners. Hardly anything of the very high chlorinated congeners. Some, but they're much lower. So then this is looking at the same slide I showed you earlier. So the top is the commercial mixture of Aerochlor 1260, and the bottom is what you see when you blow air across it. And that's reflected in the basement air. All of these low chlorinated congeners. Now, you may metabolize them quickly, but that doesn't mean they don't do something. And then this is looking at the congener profile in the blood of the people living in that house. This is just one pair, a man and woman. And I know you can't read those numbers, but suffice it to say that a lot of those low chlorinated PCB congeners were not found in their blood, which means that they were being metabolized rather quickly. It doesn't mean they were not present in the blood, but they were not present at a concentration high enough to be detected in the blood. These are the non-persistent congeners. These are the more persistent congeners. Now, the ones I showed you, PCB 28 and 99, those were present both in the blood and in the air. But most of the PCBs on the left axis, they're high in the blood, but they're not high in the air. And that's because the route of exposure was primarily from eating animal fats. Now, this is looking at the correlation between the PCBs in the basement air to the living room air. Now, a number of 1.00 would mean it's exactly the same. But between the basement air and the living room air, 95% the same. So the congeners that I showed you in that graph from basement air are pretty much what's in the living room air. However, and I didn't point out on that last slide, that the concentration, let me go back to that. The concentration in the living room air is much less. The basement air was 125, the living room air was 50. So there's less in the living room air, but the profile of the PCBs are the same ones. So you're getting all of those low chlorinated congeners. Now, if you look at the outdoor air as compared to the basement air, it's less similar. The living room air is a little more like the outdoor air, but it's still primarily reflecting what was in the basement air. There is very little association with the pure Aerochlor mixtures. There was some association with the vapors from Aerochlor 1254 and 1260, but actually they found that the best mix was a 3-to-1 mixture of the vapor of Aerochlor 1254 and 1 part of 1260. So what does this mean? It means that PCBs are migrating into these homes, primarily through the basement, just like radon does. And what's in the basement gets in the living room. And people living in this house were breathing this crap all the time they're in the house. Now this, again, indoor air is more concentrated than outdoor air with PCBs. And yet everything I'd shown you earlier was talking about diseases from outdoor air. Okay, so what else do PCBs do? And I don't have time to go in all of that, but there's a lot of evidence that they damage brain function. We know something about the mechanisms where they do that. My group has done a lot of laboratory studies in animals showing that PCBs can actually kill cells. They can block electrophysiological things that are related to learning and memory. Our work with the Mohawks, we've demonstrated reduced IQ in children in relation, well, I shouldn't say reduced IQ, reduced performance on cognitive function tests in children with higher PCB levels. And then we demonstrated the same thing in a different study of adults. The higher the PCBs, the poorer their memory. So these things do pretty nasty things. So just to conclude, you can be exposed to PCBs through a variety of ways. While the general party line is that you don't have to worry about anything except ingestion, our results increasingly suggest that ingestion may not be anywhere near the most important source. These higher chlorinated PCBs, they get stashed away in your body fat. You can't break them down very easily. We know that when PCBs are broken down, they generate reactive intermediates that are probably what is primarily responsible for the damage. So the primary route of exposure in this whole area is likely to be from the PCBs in the air. We all breathe all the time. If you're living in an area you have contaminated soil in your backyard, it's going to get into your house. You're going to be breathing it. The only solution is to get rid of the PCBs. Now, unfortunately, that's not a trivial problem. Putting them in a secure landfill sounds good, but they're still going to volatilize through the landfill. No matter what kind of a seal you have underneath it, sooner or later that's going to get broken. They're going to leach out into groundwater. So this is a real problem. There's no easy solution. It's very expensive to get rid of them, but it's very expensive to be exposed to them because it causes disease. It causes diseases in children where we're most concerned about neurobehavioral development, but it causes all those common chronic diseases of adulthood as well. They're not the only cause. I certainly am not saying that, but they increase the risk beyond those other factors that are important as well. So thank you for your attention, and I'll try to answer any questions you have. Yes?
I have a question. I know that you're talking especially that the PCBs will be in the air. I don't think these people in Stockbridge, Pittsfield, Great Barrington, Sheffield, all these trucks going through our town, if this goes through, which is not gonna, it's not gonna, but if it did, you know, all these trucks going through our town for the next 13 years, it's gonna spread it.
Absolutely right.
You know, and I've been telling them that. People think you're crazy, but they don't realize 13 years, they say 13 years, and it's going to be going, it's going to make everybody sick.
Well, if you couldn't hear the comment, all the trucks that are going to be going through the streets of this whole area carrying the dredged sediments are going to contribute to the pollution. You're absolutely right. There'll be particulates containing PCBs. PCBs go in the air when sediments dry. So one of the worst things is when you have wet contaminated sediments exposed to the air, because as the sediments dry, the PCBs go into the air. And everyone living within 3 miles of wherever they come out of is going to be exposed.
I would say Berkshire County goodbye.
Yes?
Well, from what you just said, doesn't that make sense then to leave them in the, like it's safer to leave them in
Well, the comment is that really safer to leave them where they are than to dredge them out. And that's a difficult one to ask, because if you leave them where they are, they will never go away. Now, if you dredge them, there will at least temporarily be an increased exposure. But think about your grandchildren. And it's a dilemma. In general, I think dredging is better than not dredging. But the problem is, are you going to get all the PCBs out, and are you still going to be left with enough to cause volatilization? All of our results suggest it doesn't take very much in the air to cause disease. And how you're going to get the levels down in any body of water to levels that don't cause elevated PCBs in the air is a real question. So I haven't really answered your question, but it's one for which there isn't an easy answer. Yeah.
So is there any data to show that where they've done cleanups successfully, let's say? I don't know if Hudson is probably not an example.
No, they don't clean up.
No, but I mean, is there any data to show that all this level of disease has gone down in areas, let's say 10 years after where they've done cleanup, or 5, I don't know.
Well, I don't think there's any health study that really deals with that issue, because the cleanup hasn't occurred long enough ago to really study that. There's clear evidence from what's the river in Wisconsin and also the Hudson, that after dredging, the concentrations in PCBs have gone down quite significantly. But the problem is they haven't gone down to a level for which EPA says it's safe to eat them, most of them, most of the species. So, again, I think the issue is, can we accept a temporary increased exposure in hopes that in the long term exposure will be less? Or is this temporary increase causing more problems than benefit? And I can't answer that question. I come down on the side that dredging is better than not dredging, but I'm not 100% confident that that's true. Yes?
Now, they want to put this landfill, they want anything under 25 parts per million. So 1 part per million is not good for you, right?
Yes. 1 part per million is your backyard.
Safe levels, if it's 25, 50, or 100, or 300.
If it's more than 50 ppm, then it has to be put in a secure landfill.
That will leak, because that plastic bag will leak.
That's right. The plastic bag will leach.
And anybody living within 3 miles of that landfill is going to be contaminated the rest of their lives, basically.
Yep, that's the issue.
For $25 million.
Yes.
Leading for you just said, first of all, what I was wondering is, how easily is it, like when they're dredging the river, they're removing this, they're planning to put this in the landfill. They said 10% of it, they estimate it to be greater than 50 parts per million. They were going to take that out of state somewhere.
Right.
First of all, I guess my first part of the question is it really easy to measure that? And my second part of the question is, can they really get that correct and get the right percentage of parts per million, to know which is the lightly contaminated versus the heavily contaminated? My second part is back to your early slides. You were talking about, aren't there, there's different number of chlorines? Is it all the same type of PCBs? It sounds like it's not just the parts per million, but what type they are. Are they all uniform that's around here?
All right, 2 questions there. Let me answer the last one, which is, are the PCBs all the same in these sediments? The answer is no. They aren't all the same. Then the first question is, how accurate is the sampling when you have 50 parts per million as the boundary between how you treat it? And the answer is that it's always inaccurate, because there's spots are going to have much higher concentrations. Some spots are going to have much lower concentration. You sample, you could go and dig up a little bit, a few grams, and that's what you sample. When 2 inches away, you might have a very different concentration. And the sampling is not inexpensive, and it's never accurate. So by taking many, many samples, you can get sort of a sense of what the average is, but that doesn't mean that you don't have whole areas that are much higher than the 50 ppm. Yes?
Can the chlorines in the PCBs combine with other organics to create even other new carcinogens?
Well, the question is, do the chlorines in the PCBs combine with other chemicals to create other chemicals? And the answer is pretty much no. There are, GE, with regard to the Hudson River, said for years that bacteria in the sediments will take all the PCBs and destroy them. That's not true. There are bacteria in sediments that can take off a few chlorines, but they cannot destroy the PCB molecule in these anaerobic sediments. PCBs are pretty non-reactive until they're broken down as by the liver in our bodies, and then they become quite reactive. But I think, PCBs in the sediments are going to sit there forever. They'll slowly dissolve in the water. They'll slowly volatilize. So over time, the percentage of high chlorinated conjugates is going to increase because of volatilization, will decrease somewhat because these bacteria can remove some of the chlorines, but they shouldn't react with other chemicals.
Katie?
Can I ask a question? First of all, I'd like to know, Dr. Carpenter, are you a vegetarian?
Nope.
Okay.
But I raise my own feed, and I don't feed my cows commercial cow food.
I used to kayak in the Housatonic River before I understood the PCB situation. So, I got my water shoes wet from the thing. I got some splashing on me from paddling. Does that mean I'm contaminated with PCBs?
Well, you're contaminated with PCBs independent of all of those things. I think one has to sort of take things with a certain amount of understanding. We all are contaminated. We're all at risk of disease from exposure to PCBs and many other chemicals. But what we need to do is understand how one gets exposed and understand that more is worse. We shouldn't freak out about things that we can't control at all, but we should strive to control things through action like Tim is taking with these masks and all these things. Do what we can to reduce our exposure, recognizing that, paddling on the Housatonic is much better than not paddling there. But don't do it every day for 50 years.
Okay, my third question is about, you kind of said that you're on the fence about dredging. Dredging may be good or not for the future or for the time being, but you are definitely against having a toxic PCB dump in our town, correct?
That's absolutely right, because a toxic dump is going to leach. It's going to volatilize, even with the best cap and the best liner. And, that's the big problem. What do we do with all these PCBs? The only cost-effective way of destroying them, and it's not cost-effective, is burning the sediment, which destroys all organic material. We don't have good methods for removing them in a cost-effective manner. That's why the only solution from when there is a cleanup is to dredge, haul them off to Texas, and put them in a super secure landfill.
Even though that puts us at risk because the dump trucks will be passing by every town for 15 years and polluting the entire river.
That's a major consideration.
Okay.
And it's always this issue of cost versus benefit. And the costs here of increased exposure are very real. The benefit is a long-term benefit, which in my judgment is still worthwhile for the future. But dredging is going to cause at least a temporary increase in PCBs in the air, increase of PCBs, especially particulates in the water. And if you have trucks carrying contaminated sediment through the community, that's going to increase exposure. I agree.
There's one person in this room that can change everything. He's sitting over there. His name is Sean Renier. He's a selectman. And he votes for the sin. We can change this outcome. He must vote to rescind. And we can take the $25 billion if you don't. We can test every single person, their blood before they start dredging, and then we can, after the dredging is complete, we can then again test everybody's blood levels and see how many cancers and how many people die from overexposure to PCBs. And it'll all be on you.
So to speak to that, Cindy, might I add, I've been privy to the company and their tactics for 20, 30 years now. When they say they're going to put low levels of PCBs in that dump, that does not exclude them from taking high levels and blending it to reduce the level. It doesn't matter if you have this much of contaminated soil or twice as much volume. It's still the same amount of contamination. They have absolutely raped the Pittsfield community. And I'm going to tell you why. They had an incinerator there that was taken off and burned in the oil back in the late 70s. They put it in. And it was burning the PCBs. It was almost 22 feet thick of oil on acres and acres of land in the groundwater. It was so much oil that you could literally just siphon it off the top and burn it. Well, incinerators are a funny thing. Once you build them to a certain spec, they've got to burn that much stuff, or else they become inefficient.
And they have to burn at a very high temperature.
To incinerate PCBs, it's 2,800 degrees. What I'm getting at is the company, in good faith, they do things sometimes in good faith, but in the long run, this is what happens. They've got this permit to burn these PCBs in this incineration, right in the middle of the city, right next to a schoolyard, literally 100 yards away from a schoolyard. And they were burning it for over a decade at that level from the stuff on site. But after a while, they had to start getting outside sources of PCBs in to burn, to keep that incinerator running at a specific optimum level. And they started taking the PCBs in from all over the country for decades, until Tim and a bunch of us at the time got the HRI together and we took them to the carpet because we saw where the license plates from these trucks that were dumping off this oil. Can you imagine that in good faith it turned out to be, they started this fiasco, but they ended up making literally tens and hundreds of millions of dollars, either outright making or avoiding cost of disposal. They will do anything to protect the bottom line. You mentioned that the Hudson is an open, it's a beautiful, open, hazardous waste site. You know what? The Housatonic is actually, I think it might even be worse, Doc, because at best in the summer, during drought, it's a stream. And they put so much stuff in that river at one time in 1967. It's in the papers, look in the archives of the people. The river was on fire.
Right.
On Mill Street. It was on fire. Can you imagine the river being on fire? So in regards to what they're telling you and what they're making you try to make you believe, it's scare tactics, big time. That's what the corporation does.
Are you saying that GE is telling me?
I'm saying, I'm giving you,
Is that what you're?
no, I'm not confirming that at all. What I'm giving you is some information,
It
some
sounded
past history. It's not an indictment on what you did, or it's not an indictment on anything you've done. I'm giving you past historical evidence. This is what they've done. Anything that they tell you, I would be highly suspect to. They are a very deceptive
Let me make it very clear for you.
Not for me,
For everybody. Let me make it very clear. I haven't talked to one person from GE ever. Never, ever. And I will not. Well, it's not exactly like that's exactly what
I'm just giving you.
I think everybody knows
flavor
GE
of the
sucks.
past.
Everybody knows GE sucks.
Just
It doesn't even need to be said.
what happened. This is what
Well, I'd like to just start to wind things up here, but I'd like to say that that incinerator that John was talking about was the first thing that HRI took on, and we, within a month's time of having our first meeting on the incinerator, GE pulled the plug on that incinerator. It had to be like 1994 or 95, some in that range. It's the first thing we did at HRI, because this thing, they used to call it Puff the Magic Dragon. Yes, and the reason they called it that is because it would puff. And sometimes, they explained to me years and years ago that sometimes it'd be puffing out white smoke. And then other days, it would be black smoke. And when you watch that incinerator, it used to go up 20 feet in the air, and there was like this inversion that would happen with it, because the smokestack, I think he said 22 feet, that's what it was, just went up so high. And then it would take a reversal and go down on the ground and just waffle through the already contaminated neighborhood of Lakewood, you know, and it was a terrible thing. And we're all musicians, John and me and a bunch of us, and we were driving home at 3 a.m. from gigs, and we were seeing these GE trucks pull in at 3 a.m. and dropping off PCBs from other places when that incinerator was only supposed to be burning what was going on at the plant. So like John says, they used it, they turned it into a commercial thing, and it was an outrage. But we did get it shut down finally. But this is part of that Lakewood neighborhood up in Pittsfield where our president of HRI lives, and they went through, you know, their homes contaminated, the local lands around their homes, just, you know, littered with barrels and things like that. So it's GE has really destroyed a lot about this community and about Berkshire County. And it doesn't just stop in Pittsfield, because they were trucking it to Dewey Lawful over in New York. They were trucking it on what we call the Route 22 corridor. So if you go down 22, if you were to stop at any of the town dumps on the way down there, there's information that say they dumped them all the way down there, and they were spreading them around everywhere. So, any other last couple of minute questions? Go ahead.
Thank you, Tim, and thank you, Dr. Carpenter, for setting this up, and thank you, everybody, for coming to get educated. This is what we're out here for, to get educated. But I have a question. You know, my theory is you say dredging's the best way, but it's going to be in the air, it's going to make everybody sick. I mean, it's going to get worse. But don't you think down the road with technology, I mean, we're going to be going to the moon pretty soon. With technology, that this could be cleaned up by treatment down the road?
Yeah, I think that's a good comment, that now there's much more understanding of how dangerous a problem this is. And when people accept that there's a problem, American ingenuity can usually find a solution. They haven't really succeeded yet, but there hasn't been a lot of focus on this issue, and there should be. So I think the more we can push industry to develop methods for cleaning up the mess that they've made, and not just industry, but academics and engineering firms and that sort of thing, that's what's needed.
And the EPA. Yeah. We had a question here.
I recently learned that in the Hudson Bay area that Rhinebeck is on Hudson Bay water, but Red Hook is on well water. And I was wondering if you studied the two different areas to see if differences in PCBs in people, air, that sort of thing.
No, I haven't done those studies. As I sort of said, even if you're on a municipal water supply, you can have PCBs in your air if it's not a really good municipal water supply. But if you're on well water, who knows what you're getting? So it's expensive to do these measurements, and so that's why there's so little information.
Well water, I just want to make a comment about well water is that the EPA has told us that don't worry because if you live within a certain perimeter of where we're going to build the dump, you have to decommission your well. That's what they have told us, David. And it's like, you can't make this stuff up, but that's what they're doing. And
Well, that's actually pretty good advice. Unfortunately.
yeah. Are we good? There's a Judy question. Let's get Judy.
David, thank you for coming. Judy Herkimer from Heal.
Hey, Judy.
We're co-plaintiffs with HRI currently before the Environmental Appeals Board, and we anticipate going forward to the First Circuit Court of Appeals in Boston to appeal the RIPER permit. My question to you, as you know, we had wanted to bring in Dr. Carrie Hornbuckle along with you, and then, like most things these days, COVID got in the way. Carrie went to New Bedford and worked with the community in New Bedford Harbor. That's also a PCB site. They have a confined disposal facility where essentially they dig a hole in the harbor and they put all of the PCB contaminated sediments into this big in a big wet water hole.
It's in the estuary.
It's right, it's not.
It's the worst thing you could do.
So Dr. Hornbuckle, with the community, conducted this study on volatilization, and the citizens themselves, with Carrie's guidance, designed a study to detect volatilized PCBs a distance away from the confined disposal facility, like you mentioned, 2 to 3 miles. And I just wonder about empowering this community to do something, because people are very, very concerned, as well they should be, and wondering what your thoughts are on that, about bringing Carrie in at some point, and if you would support something like a study, a community-based citizen study like that, to find out how far away from either the river or the upland disposal facility that is proposed that we hope to stop, and allow the community to decide their own fate.
Well, I would strongly support that. Now, the problem is that that's expensive, because if you're going to measure PCBs in air, it's probably going to cost a minimum of $500 per sample. I think that project in New Bedford that Carrie was involved in, I know her well, she's a fantastic scientist. I think that was supported by their Superfund grant at the University of Iowa that has a community outreach component, but that gave them the funds to actually do the study. You can mobilize people in the community to collect the samples, but if you don't have the funds to analyze them, it's a waste. So I wish I had a simple answer for where you can find a pot of money to do that kind of thing. Maybe our comedian here is going to come up with that.
Yeah.
PCB lab is shut down, right?
I don't have a PCB lab any longer. There's a very good lab that's not as expensive as some in Ontario that I recommend for use. but it still is expensive.
Thank you for coming.
Thanks, Judy. Good to see you.
Yes, thank you.